Today we continue the conversation and lessons on percents by talking about percent of change and percent of error. Two things that are kind of the same. A percent of change being when one value changes to another value, what is the percent that original value has actually changed by to give you the new value. Percent error being I've estimated a value, but this is what actually happened. What is the percent of error that that differentiates my estimate from the actual value. Percent of error is something that's used very commonly in experiments. So let's get into our vocabulary. A percent of change is a ratio that compares the change in quantity to the original amount. Percent of change is equal to the amount in change over the original amount. So while we were doing our notes, this is the vocabulary that I want you to take down. We are going to take this formula down, but also we are going to take it and break it down further so that we have something that's easier to work with. A percent error, okay, that is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. Again, a percent error is calculated by dividing the amount of error by the actual amount. So we are going to find, whenever we go over this formula more closely, it's going to help us do this calculation as well, as they're both the same type of calculation. They're both the same. They're both the same type of formula. Just knowing what values to put where in the formula and why they fit where they fit. A percent of decrease is the ratio of an amount of decrease to the original amount expressed as a percent, and a percent of increase is the ratio of the amount of increase to the original amount expressed as a percent. Now, in your book looks at amounts of change and percents of change as all being positive. Now we know when I send you guys on to 8th grade and high school, a percent of decrease is going to be known as a negative amount of change, and a percent of increase is going to be known as a positive. So for this lesson, we're actually going to start practicing this knowledge so that going forward it's not hard to transition into knowing that a percent decrease should be a negative value and a percent increase should be a positive value when you do your calculations. Okay, so let's get into some examples. But before we do that, like I said, I want to break down this formula. A percent change, you guys already wrote this down, is a ratio that compares the change in quantity to the original amount. Here's what we didn't write down. How do you calculate the amount of change? Well, if I know that one number changes from, let's say for example, I have $10 and tomorrow I have $14. The amount of change is $4. I know that if I had 10 and I went up to 14, 14 minus 10 is going to equal to 4. So the amount of change is going to be my new minus my old, that's going to be $4. So my original amount would still remain at the $10. So we're going to take this formula and we're actually going to break it down so that we can always remember what to do to calculate each of these two amounts. And we're going to say percent change, or percent of change, but we're going to say percent change for short, is equal to my original value. Wait, scrap that, sorry. My new value minus my original value divided by the original value. Now this is going to give me a decimal usually, unless my percent of change is greater than 100% or equal to 100%. This is going to give me a decimal. So in order to change that decimal into a percent, we always say move the decimal 2 places to the right, or just multiply by 100. Multiplying by 100 moves your decimal 2 places to the right, but it's also by definition changing you into a percent because a percent is always a part out of 100. Okay, so whenever we're doing our examples, this is the formula that we're going to focus on using. Alright, the same is true for a percent of error. If I estimate a value and I obtain a different value and I carry out the experiment or whatever the case might be, my estimate is going to be my original value. My new value is going to be what actually happens, and again, the estimate is going to be the original. So let's do some examples. Jonas has been saving for a video game. Last year it cost $28. This year it costs $36. Find the percent of change in the cost and round your answer to the nearest whole percent if necessary. So in this case, we're going to find that we're going to get a decimal answer. We're going to want it rounded to the nearest whole percent. And for these examples, I'm going to show you how to use your calculator to do them so that you're not going at the calculator work incorrectly. So let's start with our important information. We know that our original value is going to be what it cost last year. So our original value is $28. Let me fix that too. And our new value is going to be what it costs this year, and that's $36. We know that our formula is new value minus original value all over our original value multiplied by 100 to get that percent. And again, we're calculating a percent change. So we plug in our values. And we have 36 minus 28 all over 28 multiplied by 100. Well, I know 36 minus 28, that's going to give me 8 over 28 times 100. And sure enough, if I go up from 28 to 36, I've increased by $8. And 8 out of 28 multiplied by 100, well, let's calculate that. So I'm going to clear out my calculator. I always like to clear out my calculator first. 8 divided by 28, that's going to be 0.28. Okay, I know that if I were to change that to a percent, I just move my decimal place 2 places over to the right, giving me 28.57. But again, we're going to multiply by 100. 28.57. Now I'm asked to round to the nearest whole percent, so that 5 right there, okay, that's great. That's 5. It is equal to 5, so we know that we can round up. So our answer here is going to be equal to a 29% increase. Since I got a positive value, I know it's an increase. Okay, and I know that my price went up from 28 to 36, so that percent of increase is 29%. All right, let's do another example. Last month, 349 books were checked out from the school library. This month, 273 books were checked out. Find the percent change in the number checked out and round to the nearest whole percent if necessary. So I can look at this and I already know that my answer should be negative because this is a decrease. So let's get our values and start working this problem out. I know that my original value is 349. And I know that my new value, which is this month, is 273. I know that a percent change is calculated at new value minus original value all over my original value multiplied by 100. So when I go to plug in my numbers, my percent change is going to be equal to 273 minus 349 all over 349 multiplied by 100. So again, let me grab that calculator, clear it out, and I'm going to do 273 minus 349. I know that's going to be a negative 76. I'm going to divide that by 349, and then I'm going to multiply that by 100. So I know my answer is going to be negative 22%. Okay. Now for you guys, what I would like to see in work, okay, I'd like to see your calculations. So we know that we know that 273 minus 349, that was negative 76 over 349 multiplied by 100. I want to see that step. Okay. And when I calculated the rest out in my calculator, I got negative 21.7, so that's going to be negative 22%. So I know that this is a final answer of a 22% decrease in the amount of books checked out. Okay? So in your final answer, if you don't want to write your negative, that's fine. If you're writing up a report about, how many books were checked out at the library, you would write this in the report as there was a 22% decrease from this month to the next. But let's say someone was looking at just your calculations to get your data and all they saw was that, they would go, oh, okay, I know, I see that negative right now. That means that that was a decrease. Okay? So let's do another example. Now, in this case, we're going to have a percent error that we're trying to calculate. Morgan estimates that it will take 12 minutes to download a movie from an online store. It actually took 15.5 minutes to download the movie. Find the percent error and round to the nearest whole percent if necessary. So, we need to figure out in this case, if I'm looking at a percent error, as we said before, there's always going to be an estimate and an actual value. Which one's the new and which one's the old? So we need to figure out which one's our original value and which one's our new value. Now, anytime you're estimating, your original value is going to be the estimate because that is the number that you thought of before you did anything. So in this case, 12 is our original value because that was what was inside Morgan's head before she downloaded anything or actually, got her actual data. So the new value would be the actual amount of time it took her to download that movie, which was 15.5 minutes. Okay, so let's get calculating. So I know my percent change is equal to my new value minus my original value. And you don't need to write the formula each time. I'm just writing it for clarity's sake. Divided by my original value multiplied by 100. Okay, so let's get calculating. So our percent change is going to be equal to 15.5 minus 12 all over 12 multiplied by 100, which is going to give me 3.5 divided by 12 multiplied by 100. Okay, again, let's take a look at how that looks in the calculator. 3.5 divided by 12, and then I'm going to multiply that by 100. So I know that since the 1 is less than 5, I'm not going to need to round up here. So my final answer is going to be a 29% increase. So in this case, a 29% error, error in the amount of time estimated. Okay, so again, if I had gotten a negative value, I know that she would have underestimated. In this case, if I had gotten a negative value, I know she would have overestimated. If I get a positive, in this case, I know she underestimated. All right, so let's get to that problem of the day. In these problems of the day, you're going to find the percent change. They gave you the values. You're going to need to tell me what the percent of change is. So if we look at the first one, I know that I'm going from 50 to 80. So the part that you need to determine is which one's the original and which one's the new. Well, if I start at 50 and I go to 80, that should be an indication of what your original is and what your new value is. Again, same thing with 138 going up to 200. All right, so good luck with these problems of the day, and I will see you guys tomorrow.